Good afternoon. Welcome to SID330, Best Practices on Implementing Your KMS Infrastructure within AWS. I'm Matt Breton. I'm part of our professional services organization, where I'm a principal within our security risk and compliance practice. For those that haven't worked with AWS professional services before, our goal is to really help our customers move on to AWS in a faster, more efficient manner. So what that means is we help them understand the problems that we've seen other customers go through and how to avoid those issues in the future for their strategic deployment. Within the security risk and compliance practice, what our goal is to really work with you to move your more sensitive workloads on. So what that means is that we help you develop your playbooks, your runbooks, your incident response plans, and we even help you if you're having a bad day respond to those problems as well. And part of what we do is work with our clients around your encryption stories as well. So recently, earlier in the year, I was the primary author on our KMS Best Practices Whitepaper. And what this session is going to do is really dive into a lot of those topics that we have there and hopefully make it so that you understand when you're actually looking to deploy KMS, how to do so successfully as well. To help the conversation along, what we're going to be referring to is our Cloud Adoption Framework. For those that haven't looked or read our Cloud Adoption Framework, first off, I highly recommend it. What this is a document that really goes through our best practices for moving your resources onto the cloud. And it's not just around the technology aspects, but it covers a number of different perspectives. We have 6 of them in total. And they cover the business, the people, the governance side of it as well. And the one we're going to concentrate on today is really the security perspective. We also have a dedicated white paper for this as well. But within that security perspective, what it does is it goes into a lot of the capabilities that you're going to need to move on to the cloud. And to help our story today, what we're going to be concentrating on is the 5 core security capabilities. And in particular, what we're going to walk through is when it comes to implementing and choosing AWS KMS, is how to implement it based upon the best practices. So what we're going to really be talking about is infrastructure security. How do you harden it? How do you ensure that it's meeting your own regulatory and internal compliance best practices? Then we're going to dive into identity and access management. How do you ensure least privilege access into these keys and the data that it's being used to protect? Then we're going to look into detective controls. Because even when you set up the identity and the controls, how do you understand that the keys are being used appropriately, that you're getting the right logging information to make better risk-based decisions going forward? And then obviously this is around encryption, so we're going to be talking about data protection itself. And finally, you're having a bad day. How do you respond to that, especially when it revolves around KMS and being able to do so in an automated way? We're moving away from the times where an incident response means that you have a giant map that's sitting up in a SOC and that you're monitoring that and you're seeing little pew-pews, essentially nations and locations that are shooting lasers at each other. But now what we're looking to do is actually automate the response chain. So it allows you to actually respond faster and more efficiently and removing some of the human interaction to ensure that you're actually responding in the most effective way possible as well. Instead of just talking around the best practices themselves, I want to make this a little bit more real life. So what we're going to actually be talking to today is about a really great e-commerce company called AnyCompany. AnyCompany is an e-commerce. They sell high-end products, which means that they're really expensive products. These are $1,000 items. They have a really great customer base today that they're able to track, and they're able to understand their buying habits of these customers today. But what they realized from talking to their customers, because they're very customer obsessed, just like AWS and Amazon is that the customers want some kind of purchase plan. They're tired of having to put all the money up front. They would like to have a purchase plan capability and essentially use loans to actually pay for this. And what AnyCompany realized is that since they have a lot of the data already on purchasing behavior and their customers, they decided they're going to actually open their own bank. They're going to create AnyCompany Bank. And what this is going to allow them to do is become a 100% digital footprint within this. So they already know their customers, they already know their buying and spending habits. They could actually determine their credit scores based upon that. Additionally, what they're able to do is actually ensure that they're going to be able to make faster decisions about this as well. And as they're making this, they want to ensure that their analytics team is able to continue to make risk-based decisions and update the overall risk posture of the organization based upon the default rates and everything that their customers are actually going through as they move forward, so that they always have a clear understanding of their overall risk posture. To further help this discussion, we're going to really be concentrating around 3 key stakeholders within this discussion. We have Paul. Paul's our IT security engineer. He's really responsible for the management of our security within any company. He's going to be responsible for ensuring that we're following best practices, that we're remaining secure. Obviously, since this is the first time we're moving into a banking organization as any company, we want to ensure that we're following best practices, that our data is secure, because that's really our lifeblood over here. We want to ensure that our customer data, especially their spending habits, what they're purchasing and all that, is going to remain secure going forward. And especially with this new application, we're going to be dealing with a lot more data. Some PCI requirements are going to come into play. He's going to be really responsible for ensuring that Sally, our software developer, understands these requirements and is building the new application to meet those requirements going forward. As I said, Sally is really our software developer. She's going to be responsible for ensuring that our customer-facing application is going to be able to handle the traffic, be able to be useful, as well as ensuring that the right people have access to this data going forward. So she's going to help architect this, and we're going to go over some of the architecture in a little bit. Then we have Watson. Watson is really responsible for our governance and compliance. He, in fact, is the head of governance and compliance within any company, and he's going to make sure that as we spin up this new bank, that it's going to meet the data protection requirements that are required from our regulators and auditors as this. He's also going to be responsible for ensuring that our data is properly protected and working hand in hand with Paul throughout this entire process. So as we start looking at this and start thinking about what this application is going to look like, we're going to have our users accessing this via web console, via web portal, I should say, over the internet, and they're going to be hitting this application. And on the back end of this application, we're obviously going to be storing data. We're going to be storing their purchasing habits. We're going to be storing their credit information. We're going to be required to store and process all this information. But then on top of that, as I mentioned, we're going to have an entire analytics team that also needs access to this information as well. Do they need access to all the information? No. But they need access to key parts of it. So what we're going to do is ensure that they have access to the data that they need in a manner that they're able to consume it and process as well, while still ensuring that we have the logging capability across all this as well. So as we look at this, we come up with a few key current requirements associated to this. First off, we're dealing with PII information, so we want to protect it. We want to protect it both in motion and at rest, and we want to ensure that it's easy for our developer to be able to use this and ensure that we're able to test against it and understand that it's properly being employed, both encryption at rest and in motion throughout our entire organization and through this application in specific. Additionally, we want to select a secure key management infrastructure. We're going to be dealing with keys. We're going to be dealing with encryption. We want to select something that allows us to remain secure, that we can show to our auditors around how it's controlled and how users have access to the keys that are stored within it. And most importantly, we don't want to necessarily manage it because we're horrible at managing keys ourselves. And then we want to ensure least access privilege. It's really hard to do that when we're having a lot of data. We want to ensure that analytics team has access to what they need, the developers have access to what they need, and that everyone is able to operate, but we're still able to show to our auditors that they only have access to the data, and then we know exactly where that data is located at all times and who's accessing it. Then, importantly, we want to be able to log this information as well. So as users are accessing our keys, as they're using it to encrypt objects, as they're using the keys across the infrastructure, we want to understand how they're being used, who's using them, and the purpose associated to that as well. So we're going to log all this information and be able to use that data to make better risk-based decisions around and be able to respond to it as well. Then finally, we want to automate the incident response. We want to be able to understand when something bad is happening, be able to respond to it quickly and effectively without having a human interaction, ideally. And if we do need a human interaction, we want to be able to be notified of the key events that are really important so that we know when we have to respond faster. Instead of just getting all the haystack thrown at us, we want to be able to quickly identify those needles in that haystack. So let's dive in. So as we start talking about this, again, we're going to relate it back to the Cloud Adoption Framework. And the first thing we want to start talking about is infrastructure controls. And as we start thinking about this, we understand that we need a key management solution. So we want to start thinking about which key management solution we want to go with. We obviously have a lot of different options. We could go with a third-party solution. We could go with a cloud HSM or a KMS. Obviously, this is a KMS talk, so we're going to go with that one. But for our purposes here, it really is going to fit what we're actually looking for, because we don't want to have to manage the infrastructure. We don't have to worry about scale. We want to be able to use it in the way that is natively integrated with the services that AWS offers as well. So when we start looking at it, we realize, first off, we already have a lot of the requirements built into it. So first off, sensitive cryptographic materials are only stored in volatile memory within AWS. So what this means, within KMS, we have a guarantee that we're not having the user's ability to export the customer master keys. And the customer master keys are really what allows you to have that chain of custody around your data itself. And more importantly, when we're talking about data in motion, any access into the KMS APIs is fully controlled and ensured that the only way to access it is using TLS with perfect forward secrecy. So now you're able to guarantee that your users are accessing it appropriately. And most importantly, what we're able to show is that AWS, and this is a firm statement, has no tooling to be able to access your cryptographic material in clear text. So this means you have a guarantee as a customer that AWS can't access your material and therefore can't decrypt anything that you're previously encrypted. We purposely designed this in a way that we do not have that tooling available, and we do not have any plans to develop that tooling. So therefore, from an auditor perspective, you can feel confident telling everyone else that you control your keys and that you have the access when you need to. When we start talking about this, though, we also take a little bit deeper dive into CMK itself, the customer master keys. And as any company, we want to understand our options available to us. So as we start looking at this, we realize that from a high-level perspective, we have two different types of keys. We have our AWS managed CMKs, and these are really CMKs that AWS spins up within your account on your behalf. And these are really tied to a specific service that needs access. So for example, when you use S3 for the first time or RDS for the first time, we'll actually deploy a RDS and S3 key in your KMS solution so that you could actually use server-side encryption natively without having your own keys to manage. Now, there's some great ability for this. We'll actually manage the rotation of these keys for you. So every 3 years, we'll actually rotate them and ensure that it's available. It also is set up so that you can't delete these keys, so you don't have to worry about that. But as I mentioned, these are limited to a specific AWS service. Your users themselves cannot use these keys for your own applications or for your own encryption purposes. And that's why we have customer-managed CMKs. So as we're looking at this, these are keys that you actually generate within AWS yourself. You actually specify if you want them to be rotated. Ideally, I would highly recommend that every key that you create is rotated because it's simple. You click a button. Literally, you tell us from the time you click that button, rotate this key in a year, or if you do it via API, you enable that parameter, and AWS will automatically rotate your key on an annual basis for you. You don't have to worry about it. It'll be done transparently in the background, and any new data that's coming into AWS that's going to use your newly rotated key will use your new key, and you still have the ability to decrypt your previous data because we'll actually manage that for you. On top of that, you could actually choose to delete these keys. You could actually schedule a key deletion event from 7 to 30 days in the future that will actually remove the key fully from AWS's infrastructure so that any data that was previously encrypted with that can never be decrypted again because the key has been fully wiped, and all this documentation is available in proof backup within our SOC report as well. Additionally, within the customer managed keys, what you also have the ability is control who or what is using those keys. So both via a CMK policy as well as an IAM policy. So with this, you're actually able to very granularly say, Sally is able to use this key for encryption and decryption purposes, or she's allowed to apply a policy to it. However, Matt is not allowed to use this key at all, and from a PCI compliance perspective, you're able to show that to your auditors to show least privilege associated to it. Additionally, within customer managed keys, you also have the ability to import your own key material. So if you want to actually import your own key material, you're able to do that to ensure that you have the root of trust and that you understand how the randomness of that key material was actually generated. And by doing that, you could actually ensure that the key material is only available within KMS when you want it to. So what this means is you could actually set up just-in-time encryption. So for example, if you were to attach an EBS volume and you're doing this programmatically, you could ensure that the key material is only available during the initial attach EBS volume event. And then from there, as long as there are no outages within AWS, your EBS volume will continue to run without needing that key material to exist within KMS. So you're actually guaranteeing that nothing is happening, no one's touching your data, no one's actually manipulating anything, or trying to spin up a new copy of this without your knowledge, because they can't be done since the key material doesn't exist. And when you do want to perform an event, you can re-import that key material into the same key, and everything will continue to work. So for the purposes of any company, what we're going to choose is a customer-managed CMKs. From talking to Paul and Watson, this really allows us the granularity and the customization we want to ensure that our employees have the access that they need, as well as be able to say what services are able to use these keys across our infrastructure as well. Then we start looking at our account strategy. We're a large growing company. We need the ability to use a multi-account strategy because we want to ensure from a compliance perspective we're able to keep the auditors within a specific account. We want to ensure the blast radius of these accounts are maintained and controlled. So for this specific application, we're going to have 3 accounts that are really going to come into play. We're going to have a generic security account. We'll call that account number 1. And this account is really going to be processing our logs and storing our log data for a lot of our events. And then we're going to have an application account. This is where our banking app is really going to live. And this is where Sally and her developers are going to push our production code into, and where our users are going to come in and actually access our application. Then we're going to also have an analytics account. This is where our analytics team actually sits. This is where their analytics application is going to live. And this is where they're going to have to process the key data that they need. So when we're looking at this account model, we actually have a few different options from a key management story as well. We could actually put all of the keys into the security account and have all of them be referenced. The keys are to a specific region and exist within a specific account, but you have the capability of using them across accounts, across regions. For this purpose, though, what we found makes the most sense is we're actually going to deploy the keys closest to the data and the application itself. What this allows us to do is ensure granularity, again, around the key policy, which we'll go into, as well as ensuring that the users and the data sit close together. This way, we don't have to worry about anything going wrong. And what this also means is that the team that needs the key will be able to sit within that same account. We could get very granular within the CMK policy as well. Now, we chose this for this model because we have these different accounts and we have the different teams. That's not saying that this centralized model won't work for you as an organization if you want to do it, but for ourselves, what we found with large organizations and key managements, it really does make sense to keep them as close to the data as possible. As we dive a little bit more into this, what we want to start doing is thinking about these key points. For any company, what we're going to be doing is actually segmenting these keys. From our perspective, we're segmenting it based upon the business unit, and by default, since it's a business unit for this banking app, it's natively also done by data classification, since this will be PCI-related information. And then what we're going to do is check that rotate key functionality. Because when we check that box on our customer managed keys with AWS imported key with the AWS managed key material, we're going to be able to automatically rotate these keys on an annual basis. Since we wanted that, the one other downside I will call out is when you use the key material import functionality, your ability to rotate those keys has a slightly different process. You can't just check that box anymore because it's your key material on the back end. What you would have to do is set up your own process to actually rotate the key alias. So think of key aliases as a DNS entry. Within DNS and routing, you don't actually have to know the full URL of the web server you're hitting. You hit the full IP address of the web server you're going to. You enter your URL address, and that natively resolves your IP address. Same thing how key aliases work. Your key alias is going to be your generic name for your key, and you're able to repoint that to your new key when you want to do a key rotation in that event. But for us, we want to keep it simple. We want to ensure everything's rotated. We don't want to worry about any of this. we're going to use a customer master key with a checkbox for rotate key annually. And then we start thinking about identity and access management. How are we going to control access to this critical key material across our infrastructure and across our teams? So to do that, we started looking at both the IAM policies as well as the CMK policies. And what we realized was IAM policies are great, but they're not sufficient alone. We have to use both of them in conjunction, or in our case, what we're deciding to do is primarily use the CMK policies itself. And the CMK policy will ensure that we can be very granular around who has access to the key and what services have access to the key as well. So often, when we look at it, what we start seeing is that what we're going to do is actually separate these keys and the data per the business unit and data classification as we talked about. But then we're going to actually have separate CMK admins from the users as well. So what we're able to do within the CMK policy is specify the specific actions that each individual should have access to the key. So what I could do now is say, this group of users have access to encrypt data, but not decrypt it. Or this group has access to manipulate our key policy, but not have any access to the encrypt or decrypt functionality. So we're separating both the admins and the users of these keys. Additionally, what we want to start doing is limit KMS actions within IAM policies. In particular, we don't want to see KMS star. What you do when you actually delegate permissions into IAM, your IAM policy then becomes your control point. If you start using admin or mutating functionality within your IAM policy, your users will be able to perform those actions. And in particular, this could be useful. For example, when we start talking about cross-account delegation, what you're able to do is essentially delegate a keys to the IAM account of that party. So for example, what we're able to start doing is say, in our example, what we could do is say our application account number 2, is going to delegate the use of a key to account number 3, our analytics account. And they're able to decrypt our data from that account. But they're not allowed to encrypt or anything else. And therefore, since we don't know the individual users within the analytics team, and they have their own process to manage the users and the permissions associated to it, we're going to trust that that admin will be able to further delegate the necessary permissions to those individual users, and we're just going to delegate access to the account level. Or what we're able to do is have explicit management of those principles within the key policy itself. So how we're going to actually work around this is we're going to say the analytics team is going to be using this specific role within that account, and only that role will have access to be able to use our key in a way that we determine. So how do you do this? So often, when you create a key for the first time, the first statement within your CMK policy will look something like this. Essentially, what this is saying is allow the principal root. So when people first see this, they normally assume that this is the root user. It is not the root user. What this is actually doing is delegating permission to IAM. And in fact, this statement here is delegating all KMS actions to IAM. So that means any IAM user or principal within the account, so if you have another IAM user or role that also has a KMS star policy, to this key, they are a full admin. They will be able to perform any action that they want against this key. So don't confuse the root in this statement for the root user, but really think of this statement as allowing IAM to further delegate permission. Now, you may want to do this, as I said in the cross-account management story, where you want to say, hey, this account, say instead of the 2s, you have 3s, so account number 3's IAM engine is allowed to have access to the encrypt and decrypt functionality, and then they could further specify who within that account could use that. But what we're going to do is actually change it slightly. We're actually going to create our own break glass admin for this within that account, within our application account itself. So what this allows us to do is say, hey, we're no longer delegating permission to IAM, but we still want to have an ability to come in and administer this key if I totally mess this up. If I mess up the key policy for the other admin, the other users, and I have a statement that denies them, I still have the ability from this role to be able to come in here and change the policy and get operational again. And furthermore, if this was an incident response, the security team could then have the ability to assume this role as well and be able to manipulate this. A key point to know that, again, this role is within the same account where the key exists. And that's a key point to be self-critical within AWS. We didn't fully document this feature, but any mutating admin call to a CMK has to occur from the account that the CMK exists within. So if you try to do a mutating call on a KMS key from an administrative perspective, so for example, you try to schedule it for deletion, you try to disable it, and you try to do it from your analytics account or your security account where the key exists within the application account, you'll actually get an error message that says that you cannot do that. So that's why this role exists within the same account. Furthermore, we start looking at the other policies that we have to include within this. So now we start looking at Sally's team. Sally is really going to be developing this. It's her team that's really going to administer this key as well from a high-level perspective. So what this means is we want her to have the ability to actually start administering some of the functions around this key. Perhaps not be able to deploy CMK policies, but she should be able to create data keys. She should be able to describe the key. She should be able to do what she needs to accomplish the job. Again, this is going to be on a per organization basis, so your administrative function may look slightly different than this. And to be fair, we have the ellipses in there to show that this is not a complete call, but you want to keep it as minimal as possible. But since we're more of a DevOps organization, she will be fully responsible for this, and she will have a statement that looks something similar to this. And again, what we're using here is a specific role. And by using individual roles for all these functions, we have the ability to then understand and monitor the use of this role. Because what we'll get to in a little bit is every action within KMS is logged to CloudTrail. This means anytime you push a policy, anytime you generate a data key, anytime you call it for encrypt or decrypt functionality, any call to KMS is logged within CloudTrail. Now we have specific roles and we understand how these roles are being used. We could better understand what the logging is going to show as well, and we can ensure that specific actions, especially within that break glass role that we talked about a few minutes ago, are used appropriately or never at all. Is anytime that break glass account is used, that break glass role is used, we want to be immediately notified of that, and we could instrument that within our CloudTrail and logging infrastructure. The other thing that we're going to start talking about within this key policy is a concept called ViaService and Grants. Often people see these, they don't really understand what they're doing within the policy. So I want to just take a minute and explain the differences and what these conditions are actually used for. So grants actually delegate a subset of the permissions to either AWS services or it could be another principal within an account. And so that allows you to use the CMK on behalf of the original user. So an example for this is if you want RDS to be able to access your encrypted DB after an outage. So let's say AWS has an outage within one of our data centers. We have to move your database to a new RDS infrastructure. We could do so seamlessly if you grant us the permission to do so, and you do that and accomplish that using grants. If you did not provide us the grant, we would initially be able to start up your RDS instance, have it operational, but you lose the ability for us to seamlessly transition and make sure it's operational in a managed service capacity. The other thing that we have is something called ViaService. And ViaService allows you to scope down API calls to a CMK based upon the AWS service from which it is called. So what does that mean? That means if I want to have a CMK that could only be used by a specific AWS service, I could do that using ViaService. So for example, if I wanted to, similar how AWS has their managed keys that's tied to a specific service, I could do the same thing and say, hey, I'm spinning up this account. I want this key to only be used within S3. Or I want this key to only be used within RDS. And I could apply this as a conditional statement within my CMK policy to enforce it as well. And it would look something like this. Here's a statement we're going to use within our CMK policy to ensure that our RDS instance, which is storing our customer data, is able to use this CMK to properly protect and encrypt the data within it. So what we see here in red is granting it the ability to list grants and create grants. And on the bottom, what you see is the ViaService. So here we tied it to RDS within the US West 1 region. So you are actually able to specify not just the service, but where that service exists as well. So from a data compliance perspective, if you're worried about GDPR, you could actually specify that this key can only be used by the services that exist within the region that you want. So in the Dublin region, for example. You're able to get very granular around this, ensure that if a key can't be used outside that region via the service, you actually ensure that that data doesn't leave that region as well. And now let's start diving a little bit deeper. Now we want to start looking at the detective controls also available to us when we choose to go with AWS KMS as well. So as we start looking at this, the primary one is obviously CloudTrail. As I mentioned before, every action that we perform within KMS is going to be logged into CloudTrail. But how do we want to correlate that and actually start using that? So from our perspective, we're going to collapse all the logs into a centralized account. And this is what the security account's really going to be there for. And what this allows us to do is A, ensure that we have a centralized point to access these logs. Now, in this example, we're obviously feeding them all into S3 because we want to ensure that we have from a retention perspective. And over time, we're able to guarantee that A, the logs haven't been changed because the only thing that's able to write these logs into this bucket on the bucket policy is CloudTrail itself. No one else has write access to these buckets. We're able to show the auditors that. We're able to then correlate this information. From here, obviously, we're talking about CloudTrail and the logging into S3. You could use whatever resources you want. You could feed that into Splunk. You could feed it into an Elk stack, whatever you want. And as you have new accounts, you could actually start understanding where your data is being used and how it's being used as well. Additionally, we want to start using some additional services as well. So what we're going to look at is config rules. For those that aren't aware, config rules really helps us ensure the overall state and configuration of our environment within our accounts itself. So in this case, what we really want to concentrate on is the RDS. We're dealing with PCI data. We trust Sally to do the right decisions throughout this entire process. But Vatsan, our compliance officer, wants to also validate that she's following the best practices and doesn't accidentally mess up. So what we're able to do is configure a config rule that says all RDS instances must be encrypted. And now we'll be able to generate reports to validate that they are encrypted and that we understand what's happening across the environment as well. So it makes Vatsan's job a lot easier. And on top of that, what we want to start doing is we're dealing with S3 again. We're going to be having a data lake for our analytics team. How do we start looking at ensuring that that data within S3 is also effectively permissioned and protected? For those that haven't seen, around a month or so ago, what we released was 2 new config rules. We have ability now to validate, is your S3 bucket open to the world from a readable and writable perspective? This used to be really troublesome, and it became very difficult for our customers to understand this. Now, what you're able to do is go into config, check these 2 items, and now you're instantly able to report on, are my buckets open to the world? And now you're able, from a reporting perspective, understand what data is available externally as well. In addition to that, we want to ensure in transit, any data that's going to this S3 bucket is properly protected as well. So we want to ensure that all access into the S3 bucket is encrypted in transit using SSL or TLS. So again, config rules is going to come into play, and it's going to ensure that we have the ability to validate that and enforce that policy as well. Previously, when we also wanted to ensure that every item in that bucket itself was encrypted, we used to have a bucket policy that looks something like this. And what this is essentially saying is, for every put object into that bucket, we want to ensure that it's using AWS KMS. This is great. It's kind of a policy. It doesn't really give us much. If I try to then perform an action and put an object, and I don't specify the KMS key that I want to use, my put request would fail. This thing causes bugs sometimes if your infrastructure isn't properly configured and set up. So AWS heard the problem, and now there's an improved method. Now you could go into your actual bucket configuration and management and actually set default encryption. So what this means now is that you're able to say, any put request to put an object into this bucket, if you don't specify an encryption method, it will automatically apply one for you. So therefore, you could now just say, put this object in. You could then, within the configuration of this, you specify what KMS key you want to use, and it will automatically apply that key to that data and have that data encrypted. So you have less to worry about. You have another fail-safe in place to ensure that any data being put into that is guaranteed to be encrypted. That's great, but I still want to know, I've been using this bucket for a little bit, how do I determine what objects aren't encrypted? Or if a compliance agent comes to me and says, hey, I understand you did this and I trust that you did this, but I still want you to prove to me that every object in here is encrypted. We heard that problem as well. You now have detailed inventory reporting. So now within the S3 bucket, you're able to specify, I want to know, is every object actually encrypted? I want to have a detailed reporting around all this. And you're able now to generate these reports so that you understand and your auditors understand where your data is, what status your data is within the accounts themselves. And you're able to actually set this up to actually generate these reports on a daily or weekly basis for you so that you're able to understand and validate with your auditors and compliance teams the state of your environment itself. Now let's dive into how this application is going to be set up and the data protections we're going to use within this. So as we've been talking about this application. Again, we're going to have these users accessing the application via the internet. We're going to be storing some data within an RDS instance. We've decided to go with KMS. This is great. We can natively encrypt that RDS instance. So what this means is, server side, every object that's going to be in there is going to be encrypted at rest. And more importantly, when we start thinking about disaster recovery and backups of it, those objects are going to be encrypted at the snapshots as well. So it's going to be encrypted using your same key, the same permissions associated to it. You don't have to worry about your snapshots being unencrypted. It'll natively encrypt those and store those within a bucket for you. Additionally, we have our analytics team here. Again, they're going to be creating this data lake. Obviously, they're creating a data lake on S3 because that's the best use of S3. And they want to ensure that all the objects that they're going to be using are also encrypted. And this is where we're going to start looking at the AWS Encryption SDK. For those that haven't looked at this before, essentially what it allows you to do is actually use KMS keys in the most effective manner possible. So in this case, what it's going to allow us to do is going to be able to query into RDS using Postgres, SQL, what have you, commands. And then from there, it's going to be able to extract the data it needs using the KMS key that was encrypted, and it'll have the permission to do so. Then what it's going to be able to do is use the new key that exists within the analytics account, because it has permission to use that, to actually take those objects and push it into the data lake that sits within S3. And it's going to be able to do that using client-side encryption as well. So it's going to self-generate the data encryption keys and be able to create the new blobs that's going to push into that data lake that will contain both the data encryption key as well as the object, both encrypted, and then you'll be able to use that same AWS Encryption SDK to decrypt them and perform your analytics on that as well. The other thing we're going to start using as well is something called Encryption Context. Encryption Context allows us to have an additional key value pair associated with our data. So what this means is when we're actually encrypting the data, we're encrypting it using an additional amount of information. And what that allows us to do is ensure when we go to decrypt it that we also have to have that same value pair as well. AWS does this natively whenever we're using KMS for encryption of your EBS volumes, your S3 objects, anything along those lines. We actually have specific metadata associated to that object to prevent the confused deputy problem. So now we have to know not only is it this specific instance that's requesting the EBS volume, but within S3, we have to know the complete destination and string of that to ensure that it should be able to be decrypted by that. We're going to be using something similar as well. We're going to be injecting a key value pair into this encryption so that we're able to ensure that our users are only accessing the data that they're specifically should be accessing. The one thing I do want you to keep in mind is the encryption context is logged in clear text within CloudTrail. So if someone has access to the CloudTrail data, they would be able to get access to the encryption context. Now, this isn't necessarily a bad thing, but what you do want to be cautious about is using PII data or sensitive information within the encryption context itself. So in case of our banking application, since it's tied to users, we never want that encryption context to be a social security number or a UID associated to that individual. We want it to be something that our applications understand and could retrieve and understand around that user in our case, but not around something that's sensitive that's being logged into clear text, or else you'll have new regulatory and compliance issues. So when we start looking at this a little bit deeper, essentially this is the flow we're going to get to, where we have this encrypted RDS instance that's pushing objects into our S3 bucket for our encrypted objects. From there, we're going to be able to extract some of those and re-encrypt it using our AWS encryption SDK and push it into the analytics bucket. And from there, the analytics team has built out their custom application using the SDK as well, as then be able to start processing these logs and understand the overall risk posture of our organization at any point in time, and more importantly, be able to tell us who's defaulting, whose credit value is still accurate, and be able to feed back that information to us so we'll constantly be able to update our application and determine who should get additional credit or whose credit should be cut off at any point in time. So again, this is going to become a complete cycle using KMS associated to the data. And notice that the only individuals that will have access to this are the individuals that need access to the data. And now we could have had the analytics team go directly off the RDS instance and be able to query that and everything, but they don't need to have access to all that information. They don't need to have access to customer actual detailed billing information. They only need access to a subset of the information. So we're going to make it easy on them and subset our data set itself. The other thing we're going to start looking at is incident response. Now we've got our infrastructure in place, we've got our logging in place, we have our secure data protection in place. How do we start understanding when we have a bad day, what do we do, how do we respond to that situation? Our answer for that is going to be CloudWatch. Natively, what we're going to start looking at is how do we understand what's happening within the data? Yes, we can start querying our CloudTrail logs, we can start looking into that, but for us, we want some automation associated to this. So one of the first CloudWatch rules we're going to create is really we want to understand every AWS KMS action and feed it into our Lambda function. And we're going to call that Lambda function validator. And what we're going to look at within this validator function is some of the details around the usage of these keys. So for example, we have this break glass account this break glass role that we created. We want to ensure that that's really not being used. If that's being used, we want to immediately understand why and what actions were taken. We also want to start looking at the other admin roles associated that we created and ensure that those are only occurring from within our IP address that we know of. We want to understand, is this access key being used across accounts? We want to understand this type of information and start alerting on it proactively, and we're going to use CloudWatch and Lambda to actually be able to automate this entire chain. This is great and all, but we also want to just have some notifications tied into this as well. So we want to know if someone's putting a new key policy on this key, if someone's actually scheduling it for deletion, if someone's disabling this key. These are events that could drastically impact our performance and the security of our data. So we want to be instantly made aware of this. And again, we're going to use CloudWatch to be able to set this up. Since CloudWatch is monitoring for all these events, we're just going to have it set up an SNS topic that we're going to receive. And now what we're able to do is actually be able to understand when these events happen, and our SOC and our security are automatically going to get paged, essentially, that this event just occurred, and we could then look into it and make sure it's valid, and that's tied to either a change management request or for a valid incident response perspective. So if we go back and actually start looking at all our initial requests, what we see is that we now are able to protect our data both at rest and in motion. We've set up those config rules to validate that our data is encrypted at rest, as well as the config rule to ensure that the S3 bucket enforces a TLS or SSL connection. Then we looked at our KMS infrastructure itself. We looked at the AWS SOC report to ensure that the employees have a clear delineation around what they're able to do. We validated that AWS can't access your encrypted keys. And then we also looked at the least privilege access from our perspective. We looked at using KMS CMK policies to actually ensure that the users and the roles associated to them only have the actions that they need access to, and that we're able to ensure that the AWS services have access to the keys when they need to have access to it. Then we set up our CloudTrail logging infrastructure to log it all into a centralized point to ensure that our Elk stack and our Splunk infrastructure is able to pull in those logs and perform the normal log correlation events that we have a requirement for. And then we also automated the identification and response to these high-risk events. Using CloudWatch events and Lambda and SNS notifications, we're able to actually understand what's happening to these keys from high-impact events and be able to respond to those quicker. Some additional slides and details for you. If you haven't read our KMS Cryptographic Details white paper, this white paper goes into very much into the weeds around how KMS is actually architected, everything from the encryption algorithms we use to how we ensure least privilege, even talks around our quorum-based access control into the HSMs themselves to ensure that no one individual could drastically change our infrastructure or make any changes. Here's the KMS best practices white paper. Again, this white paper will go a little bit more in depth into what we talked about today. But it'll give you some more examples and some more details around some of the topics. And from a compliance reporting perspective, we have an entire list of all our compliance reports so that if you wanted to better understand our SOC 1, our PCI compliance, HIPAA compliance, go to this website and you'll be able to understand that as well. There are a few other reInvent sessions if you're interested in this one. I hope you can also look at these. If you weren't able to attend them at this reInvent today, or this week, I should say, generally speaking, all of our sessions will be live on YouTube and SlideShare within a few days, so you'll be able to check those out as well. Most importantly, please fill out the survey. We live and breathe by data. We need your data. And with that, thank you very much. If you have any questions, I'll be up here, so feel free to ask anything else.